Hello everyone, it's September the 17th. I took it easy today. I think I finished work around 8 o'clock. I trained, come back, watch some videos. I'm gonna watch some more, and then we're gonna do this. Oh my goodness, it's an old problem. Written in Python, not that long time ago. All right, we have a task management system that allows users to manage their tasks, each associated with a priority. The system should efficiently handle adding, modifying, executing, and removing tasks, implementing the class such that task manager is an array of array, initializing it with a list of user task priority triplets. Each element in the input list is of the form user ID, task ID, and priority, which adds a task to the specified user with the given priority. The next one adds a task with the specified task ID and priority to the user with user ID. It is guaranteed that task ID does not exist in the system. Edit updates the priority of the existing task ID with a new priority. It is guaranteed that task ID exists. So I don't have to do a lot of... See, this is the difference between a toy problem and a real problem. The real problem, you see all this is just, error handling, and error handling. In a toy problem, they tell you that it's guaranteed that task does not exist. It tells you the task does exist, but in reality, no, you have to handle these. So yeah, so in reality, it's less fun, right? You have the fun part of designing this algorithm, which most likely is going to be the same as yesterday. We have a priority queue, we have a map, and then we just do the same thing as we did yesterday. But in reality, you have all of these edge cases that you have to consider and you have to test for. That is the difference. One of the difference between a toy problem and a real problem. But hey, we do this for the fun. Right, so I don't want to do it in the real problem. I don't want to write all those, check those error cases. No, I don't want. What I want is just to go ahead and have fun. And remove. And then, and guarantee that task ID exists in the system for remove and execute top. What execute with the highest priority across all users. If there are multiple tasks with the same highest priority, execute the one with the highest task ID. Okay. After executing, the task ID is removed from the system, which we can use this. Return the user ID associated with the executed task. If no tasks are available, return -1. A user might be assigned multiple tasks. So we definitely need a map from task ID to priority, right? We need a task ID to priority. And we also need user ID. So I mean, the original, this can be, right? This can be what we want. But the mapping from user ID and task ID, it doesn't have to be inside, right? It doesn't have to be inside. So it can be another map, right? We say add. So we need a task ID to user ID as well, right? Two maps. Edit, we do this. Add, we'll do this, and we'll do this. And remove, we just remove this and remove this. Yep, that's about it. That is about it. Oh, I want to use some private, just like yesterday. So we have an unordered map int. This is a task to priority. And then we need unordered map. This is task to user. All right, and then we need I remember it's inline inline static auto comp, right? So we need to do some comparison, which is going to be I'm gonna do pair. I like pair. So this is gonna be P1 pair. This is gonna be P2. So the pair is equal to, it doesn't really matter which one is front and which one is second, but I think what we're gonna do is let's put task, let's put priority first. Oh wait, hold a second. So priority is a max heap, but task ID with the highest, I don't need this. I don't need this. Priority queue pair int. Yeah, this is just a max heap, right? PQ max heap for priority and task ID. Yeah, because we want the maximum priority and the highest task ID. So, okay. So that's that. Now we need to initialize it. We can say for auto, const auto t task of tasks, right? So what we have is user ID, task ID, and priority. So UID 0, task ID, and P priority. Okay, and then we'll do task to user, task ID will equal to UID, and task to priority, task ID will equal to priority, and priority queue dot push, we're gonna go priority and task TID. All right, so add a task. How do we add a task? So we add a task, we say task to priority, task ID will equal to priority, and task to user, task ID will equal to user ID, and then pq.push priority and then task ID. Done. Edit. We just basically say task to priority, task to priority, task ID will equal to new priority. That's it. Remove. Task to priority dot remove, delete, erase. There we go. Erase task ID. I think that should be fine, right? And task to user dot erase task ID. All right, now execute. So we say while -1. So while p pq dot empty. It's not empty. Okay. And so const auto p equal to pq dot top if p dot second, right? If task 2 priority dot contains p dot second, right? And task priority p dot second is equal to p dot first. That's a match. I say rest shall equal to task to user p dot second, and then call remove p dot second. Right, we'll do that. And then we'll pop it. Yeah. We actually need to break this. And rest is smaller than 0. Right? Which means I haven't found it, and then this is not empty, but if it's empty, we'll jump out. So we do that, remove, and then if else, we always do pq dot pop. And then when it gets out, we just return rest. Alright, that looks decent to me. 3408 hash map and priority queue. Let's call it max heap. Okay, let's see. Alright, looks to be solid. I mean, the logic itself is not really that hard. But we got a wrong answer. Ugh. Interesting. Alright, now I have to figure it out. It's supposed to be 2, but I got 1. Where did I got wrong? So we have TP. Okay. So task, unless it's user, task, and priority. Okay, user, task, priority. So 1 just to 8. User. All right, 102. Oh, and then priority queue. Plus 8, 101. So 102, 20, 102, 2, and then 20, 102. And then 103, priority, 103, and then edit. Oh, I think I know why. Because I edit its priority. Oh, hold a second. That's priority. I think user need to change as well, maybe. Maybe. User need to change. Oh, wait, hold on. One task can be done by multiple users, right? A user may be assigned multiple tasks, but one task can only be assigned to one user. Nah, I don't think that was the reason. Okay, so we have 20, and the last one is 5. No, yeah, 5 is its priority, and 103. All right, so first is add. So we add 1. So we have 104. Priority is 5, and then 104. User is 4, and then we should push it in 5 and then 104. Edit. So 102. Edit. Oh, I forgot to push. My bad. I think edit need to push as well. Yeah. Blah blah blah. I forgot to push. That is on me. That was on me. I forgot. So it's more of a silly mistake compared to, it's not like something we did logically wrong. I think it's just a silly mistake. You edit, you have to push it in. I just forgot to push. But it's still not right. Okay, now this is different. No, it's because priority goes first, dumbass. Did you put priority first? Yes, you should always put priority first. There we go. Yeah, that was just a silly mistake. I kind of ruined. I could have finished this without getting any error. I wonder if my previous error was due to the same reason. So yeah, you see that having the hovering thing does not really impact the usage of the UI, which means it's, I don't know. Alright, I'm just curious. That was a runtime error. What did you do? Key error. I probably forgot some key. Yeah, it's all programming issues. All programming issues. Alright, not bad. That's good.